Here we are designing a context-free grammar for some languages. So here 3 languages are there. First we can take one language. That first language you can take. So in this, what does that language indicates? It will be having A followed with the I number of A's followed with J number of B followed with C number of J number of C followed with I number of D. So the A as well as D count will be the same and B and C count will be the same. Also it is given that I comma j value, it should be greater than 0. So based on the first problem, the language will be having some elements. What is the minimum length string that is belonging to this language? Since ij value is greater than 0, the minimum string will be A, B, C, D. Okay, so A, B, C, D. Then next minimum string can be taken as A, B, C, D, D. This can be taken as a minimum string. Again, A, B, B, C, C, D. Okay, like that it goes on. So only condition that is satisfied over here is the number of B's as well as number of C's, it should be same. Number of A and number of D also, it should be same. The order, it should follow the correct order. Okay, so keeping everything in this mind, these things in mind, what you have to do, you have to design the context-free grammar. So we can start with the start symbol. Let it be S. So S gives what is equal number of A's and equal number of D's is there, isn't it? So first A, if there is a A at first, means you should have D towards the end, that same count, and this can be repeated any number of times. Okay, this can be repeated any number of times. So this right hand side, it helps in managing the number of A's as well as the number of D's. So this is a case with what A and D alone, but we have to see about this B and C also. So for B and C, you can just give it like either it can take A as D, or you insert some new non-terminal A, X, D. Here ASD means any number of times you can have any number of times you can have A and D, and it should be same. Occurrence of A as well as D should be same. So for that purpose you can use this ASD. This AXD, the purpose of using this right hand side is like this protection is now the occurrence of A and D is coming to an end. In middle part, that is this X has to be used to insert the terminals B and C. So X terminal can be defined as B, X, C, and X can be taken as BXC, and since ij value is equal to greater than 0, we cannot include epsilon here. We have to include what? BC. Okay, so here what we have done here is as two non-terminals you have inserted. Two non-terminals you have inserted, S and X. S will be used to manage the A's and D's occurrence in the string, and capital X will be used to manage the occurrence of B as well as C. Okay, so if I um, this is the final answer for the first question. Okay, the required CFG or the CFG design for the first question will be these two non-terminals and its productions. So after designing the after giving the listing out these productions, you have to write the tuples also, like V is equal to G is equal to VTPS, V is equal to set S comma X, like that. T is equal to A comma B comma C comma D. Then S is the start symbol. Okay. So this is the required context-free. This is the context-free grammar designed for the language L of G. Now we can see the second example. So what is the second example here shows? I comma j, it should be greater than or equal to 0. Okay, I comma j, it should be greater than, same language, only difference is I comma j, it should be greater than or equal to 0. So we can modify this thing. This grammar itself we will be able to modify. How you can start? You can start with identifying the elements inside the language. So what is the minimum string that will be accepted by the language for this question? I comma j greater than or equal to 0, which means that language will be accepting epsilon. Then it can take AD, BC, then ABCD, AADD, BBCC, like that it goes on. Okay, so which means that it can accept epsilon, AD, BC. These are the minimum strings. So how you can modify this grammar? Since epsilon is being accepted, you can take it as, so this is the answer for the first question. Second question answer I am listing out. Okay, so epsilon, so S from the start symbol, since epsilon need to be accepted, epsilon will be inserted. Okay, then as defined in the previous thing, you can insert this ASD in order to monitor the number of in order to monitor the occurrence of A and D, because those should be the count should be the same for A and D. For that, ASD is included. And then since BC is also being accepted from the accepted for this language, it can start with B as well as end with SC, isn't it? So you can insert one more production, that is B X C, BXC. Okay, so this helps in this production helps in starting with the terminal B. This production helps in starting with the terminal A, and this production helps in starting with the terminal B. Now, so this is the change for the start symbol. Then X, we can define for X. So X again, since I comma j value is greater than or equal to 0, X can be epsilon, then any number of B's and C's can be there, isn't it? So B, X, C. Okay. Now, is it necessary to include a BC here? Minimum string is BC, isn't it? But since I am using this epsilon, you will be able to substitute this epsilon over from the start symbol. uh, if you are taking this BXC as the first production and and deriving any string means substituting epsilon in place of this X, you will be getting this BC. So it is not necessary to include this BC. Okay. So this is the final answer for the second question. So what is the difference here you got? Like epsilon productions will be included, and also since BC is accepted by the language, in order to include that you have inserted this BXC production. Okay. Starting with the B, ending if the string starts with B, then start symbol it uses the first production as BXC and then proceeds with the operation. Okay, now third language is, it will be having a terminal X in between. It is having a terminal X in between. So what is the minimum string accepted by the language? Is it epsilon? No. Minimum string accepted will be X. I comma j greater than 0, greater than or equal to 0. So for that the minimum string which will be accepted by the language is X. Then comes AXD or BXC or AXDD, ABXCD, like that it goes on. Okay, so what changes we need to apply in order to get this thing done? Only change what you have to apply is, since the ij value is greater than or equal to 0, instead of this epsilon you have to insert since I comma j value is greater than or equal to 0 and the minimum string accepted by the language is X, in place of this epsilon you have to give the value as X. So the grammar generated for the third language will be like, S gives, X will be the minimum string, then the production for equal number of A's and D's you can write like this. Equal number, in order to start with the in order to start with B you can write the production like this. Then expand the for X non-terminal you can insert again X, then BXC. So this is the final set of productions for the given language. Okay, context-free grammar. So we can see one more example, some more examples, like if write the context-free grammar for the language. L is equal to set A raised to n, B raised to m, such that n comma m greater than 0. So what is a grammar that can be generated from this? What is the meaning of this language? N number of A's followed with M number of B's. No relation between them. Whether they are equal, no. It can be different also. It can be same also. Not equal, it is not given as they are same or they are not same. But only condition they are mentioning is n comma m, it should be greater than 0. So n number of A's followed with m number of B's. These are the information you will be getting from this language. So this minimum string will be what? Anyway, minimum string will be AB because n comma m is greater than 0. So with this you have to design the grammar like starting with the start symbol S. In order to monitor the number of A's, you can use it should start with A, isn't it? It should start with A. So in order to, any number of A's can be there, n number of A's. So there is no specific count, n number of A's. So for that, you can introduce the protection as A, S. Okay, AS, which helps in introducing this protection. It helps in deriving any number of A's. Okay, then similarly for BM also you can take it as you can take another one protection T. Not T, you can take another. A, B, B, A. Okay, so this protection, it helps in deriving n number of A's. That is, if you take AS, again in place of this S, you can substitute, you can use this AS again, so you will be getting AS, like that it goes on, isn't it? So any number of A's can be taken with the help of this S giving AS. Similarly, for A giving BA also, you can take any number of A's. And since n comma m value is greater than 0, you have to use A, and here also you have to use B. Okay. Now, what next is, you need to combine these two, isn't it? A and B. Separate non-terminals are given to define this A and occurrence of A and B. So to combine this, you can introduce a new non-terminal, and that can be treated to be as the start symbol, in which it will be having the right hand side as SA. Okay, S indicates the n number of A's, and A indicates the m number of B's. So the final set of protections can be, or the context-free grammar defined for this language can be written like this. X giving SA, S giving SA, S giving AS A, and A giving BA B. Suppose instead of this n comma m greater than 0, I am taking n comma m greater than or equal to 0. What will be the change you will be getting? You can make this, instead of this a and b, you can make it as epsilon. Sorry, not correct, epsilon. Okay, instead of a and b, you can insert epsilon. So for this question, the final answer will be like this will be the final answer. S gives SA, is X gives SA, S gives AS, A bar epsilon, and then A gives BA bar epsilon. Okay. Now next is like if a condition is given, L is equal to language, L is equal to set A raised to n, B raised to 2n such that n is greater than or equal to 0. So what is the meaning of this? N is followed with twice followed with b, which is which its count is twice that of the a. Okay, so a raised to n, b raised to 2n. So what we have done earlier, same concept you can apply here also. Only difference is you need to identify the minimum string. So here the minimum string is if it is a, so greater than or equal to 0. So a, if it is occurred once, means b should be there twice. Okay, so how you can generalize it in a grammar? 2 a's means you need to have 4 b's. Like that it goes on. So grammar can be taken as L is equal to, so here only one condition is there, isn't it? Sorry, not L, S is equal to S gives, only one condition is there, that is number of B's will be twice that of the number of A's. So you can start with A, S, B, B. If there is a single A, 2 B's should be come to the right. This can be repeated by inserting that S non-terminal in between. Okay, so repeating this, you will be getting the count. And since it is greater than or equal to 0, oh sorry, here it is greater than or equal to 0. So here the language should accept epsilon also. Okay, the minimum string is epsilon. So here you can just insert epsilon also inside the grammar. Okay. If the language is given like L is equal to set A raised to n, B raised to 2n, C raised to m, such that n greater than or equal to 0. So here one more combination, one more terminal is inserted, that is C, and its occurrence, it is not related to the A and B. It should be at the end of the it is after B only this C should occur. That's the only case. So here, how you can define? So these two terminals, they are related and C is different. So you can start with grammar X S A, like that you can start. S is used to monitor or manage the occurrence of A and B. A will be like M number of C's. So based on that you have to design. So here N is greater than or equal to 0. Sorry, and M also is greater than or equal to 0. N comma M greater than or equal to 0. So the language will be having what? The minimum string as epsilon. So you can epsilon will also be accepted by the language. And S, so S can be designed as either it can be epsilon or A raised to n, B raised to n. Appam A, S, B, B. Similarly, for A also it can be epsilon or what is the purpose of this A non-terminal? In order to have M number of C's. So M number of C's means any number of C's. So C, A. So this will be the grammar generated. Now we can see one more example. L is equal to 0 raised to I, 1 raised to j, 2 raised to k, such that I equal to j or j equal to k. Okay, so here only this much condition is given. If the terminals will be taking 0, 1 and 2. If the string can be either the number of zeros and ones can be the same or the number of ones and twos can be the same. Okay, two languages, they are combined using this OR. Either it will be accepting the strings in which the number of zeros and ones is same. Also it will be accepting the strings which will be having ones and twos also the same number of ones and twos. So for that again you have to make use of you have to generate the strings for the language. What is the minimum length string? Epsilon, because if the number of zeros and ones as well as twos, if it is not there, means that also will be an element of the language, because the it is not given I value as well as j value, whether it is greater than or equal to 0, it is not given. Only thing is, if 0 is there, 1 should be there, or if 1 is there, 0 should be there. So 0, 1 can be an element, 1, 2 also can be an element. Zeros 0, 1, two can also be an element. Like that it goes. Okay. Now we can start with the symbol. Like first we can see with 0, 1 same. We can make it like X gives AB, and A will be monitoring the count of zeros and ones. B can be defined such that it helps in uh, monitoring the ones and twos. Okay. Once again, one second. So here you can see it in a different way. So as I have said, there is two languages, isn't it? L1 is equal to 0i 1j 2 raised to k such that I value equal to j. That is one language. L2 is equal to 0i 1 j 2k such that j is equal to k. So L1 union L2 will be the language. So first you can design a context free grammar. Individually you see for L1 and L2. Design context free grammar first separately. So consider the language L1. So in this I value is equal to j, isn't it? So for that you can take it as x gives AB. A helps in monitoring the zeros and ones, which should be the same. So you can write it like A 0 A 1, and it can also take epsilon, so epsilon also is there. Then B, in that case B, that is 2, isn't it? B will be taking care of the terminal 2, and the count, it is independent of 0 and 1. So any number of B's you can take based on the language L1. Any number of B's or epsilon. So this is L1 for L1, and for L2 also how you can take. For L2 also you can take it as Y gives CD. So what does that C indicates? C will be like any number of zeros, isn't it? For L2 language, J value should be equal to K. So C can be any number of zeros. You can write it like 0C epsilon, and D can be like it manages the number of ones and twos, same number of ones and twos. So 1 D 2 or epsilon. Okay, now what we have to see here? L1 union L2. L1 union L2. So what you have to do? You have to mix up these set of productions that is derived for L1 as well as the L2. L1 as well as L2 can be mixed up together. So L1 union L2, the grammar need to be generated. So what does that mean? Either it will be satisfying the strings of L1, or it can accept the strings of L2, or it can derive the strings of L2. So for that, separate non-terminals. Let give a new start symbol, that is S. S gives X or Y. In order to implement this L1 union L2, L1 start symbol was X and L2 start symbol was Y. So in order to implement L1 union L2, you are introducing a new start symbol S, which can accept either X or Y. So the given set of grammar will be like um, the start symbol. With the new start symbol, S gives x, y, x or y. So here grammar can be taken as S gives x or y, followed with the rest of the non-terminals. X gives AB, x gives AB, then A gives 0 A1 epsilon, B gives 2B epsilon, Y gives CD, C gives 0 C epsilon, D gives 1 D2 epsilon. So these set of grammars will be forming these set of productions will be forming the grammar for the given language L1 union L2. That is, L is equal to 0i, 1j, 2k, I is equal to j, or j is equal to